So today we're going to learn how to convert from degrees into radians and vice versa. So degrees and radians, you probably have heard of degrees based on yesterday, and probably even before that. Most likely you have not heard of radian measurements. And just like the length of a highway can be measured in terms of miles or kilometers, we can measure an angle, an interior angle, in terms of degrees or in terms of radian measurements. Most students prefer degrees, even myself, because it's just plain numbers. But within math and when applying to application problems, we generally always use, and even with graphing, we generally always use radian measurements. Okay, so we all know that this is 30 degrees. So I'm going to write 30 degrees right here. Now, I'd like you to take notes on a lined piece of paper. You can continue from what you did yesterday. I'll zoom in here and then zoom out when we're done taking notes on this portion. And I'll explain it at the exact same time. So degrees and radians measure interior angles. We can rewrite a degree measurement into radians by multiplying by pi over 180. All degrees will have a little degree measurement. All radians will contain the pi symbol. So for an example, if I give you 30 degrees and I say, please convert it into radians, I'll multiply by pi over 180. I'll push the numerators together, and then I'm going to take 30 over 180. And there's multiple ways you can do this, but ultimately you're going to reduce the 30 over 180. So the zeros can cancel out, and 3 over 18 reduces to 1/6. So 1 pi over 6. This radian measurement is equivalent to this degree measurement. Okay, now vice versa. Now I want you to take a radian measurement, which you know is going to contain a pi symbol, and I want you to convert it into degrees. How do you do that? So if we start with 1 pi over 6, we already know from the previous problem that 1 pi over 6 is equivalent to 30. Well, how do we get that? We take 1 pi over 6 and we multiply it by 180 over pi. We push the numerators and the denominators together. The pi symbols cancel, and 180 divided by 6 is 30, so 30 degrees. Does anybody need more time to write this down? Hands up high? Okay. Okay, so I'm going to get started. I'm going to go back here. Get this from your partner if you need to write it down a little bit more. I'm going to zoom out. And every one of these bulleted points along the unit circle, we already yesterday learned how to figure out what is the degrees of it, right? 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on. It would take a long time for me to say, okay, please go to every one of the bullet points. I gave you degrees. Please now convert it into radians. That would take a long time, correct? So today I'm going to try to teach you a faster way of doing that. Do not feel the need to highlight. Just watch mine, please. Let's start with 30s. I'm going to bring this down here. So I'm going to take this sector, and I'm going to ask you in the top part of this unit circle, so the only part that you can see on the screen right now, how many equal sectors are there that are this exact size. Turn to your partner. You have 5 seconds to decide. Go. So I've heard different options. I've heard 3 is very common. I've heard 4, and I've heard 6. Hands up, who believes 3? 4? 6? Who's having a hard time even right now understanding what I'm talking about? Okay, so here's one. If I could take and cut this out, do you see how I could paste it right here? That'd be a second one. And I could take it and put it over the top of this sector. That's a third, a fourth, a fifth, and a sixth. So hopefully right now you can see how there are 6 equivalent sectors that are this size. Can you raise your hand so I understand if you're getting this? Hands up high if you're getting this right now. Okay. The 6 is key. 6. There's 6 equal sectors on top. So we're going to go to every 30-degree mark. And if you're like, what does she mean by 30s? Remember, 45s are specifically here, right? We're going to go to every 30-degree mark, and we're going to count by 6s. Please right now do it on the outside of the circle, and don't do it where you see an ordered pair. 1 pi over 6, jump up. 2 pi over 6, jump. Sorry, there's not much room here. 3 pi over 6. 4 pi over 6. I'm going to keep going here. 5 pi over 6, 6 pi over 6, and continue to go around the unit circle. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. That ends one revolution around the circle. Okay, now we need to ask ourselves, is every single one of the fractions I put down, are they reduced? If they're reduced, I'm going to take whatever that number is and I'm going to copy and paste it onto this line. So 1/6 cannot be reduced, so I'm going to write 1 pi over 6, circle. But 2 pi over 6 can be reduced. So do you guys want me to zoom in to start with? Is that a little more helpful? So 2 pi over 6 can be reduced. Please let me know as I move around the unit circle if I need to adjust the paper so everybody can see. 2 pi over 6, they're both even. Let's divide by 2 to get 1 pi over 3. 3 pi over 6 reduces, divide both by 3, 1 pi over 2. 4 pi over 6 reduces, divide both by 2, 2 pi over 3. 5 pi over 6 does not reduce. 6 pi over 6 reduces just to 1 pi. 7 pi over 6 does not reduce. 8 pi over 6 reduces, dividing both by 2, to 4 pi over 3. 9 pi over 6, I can divide both by 3 to get 3 pi over 2. Both even, divide both by 2 to come up with 5 pi over 3. 11 pi over 6 does not reduce. And 12 pi reduces to 2 pi. This is our starting point actually at 0. 0 degrees and 0 pi. Students in the past have asked me today, does it matter whether I write the degrees on the solid line and the radian measurements on the dotted line? It makes no difference to me. Okay? They both represent the measure of this interior angle. So, things that are equivalent, just like 6 divided by 2 is equivalent to 3. 10 divided by 5 is equivalent to 2. 30 degrees is equivalent to 1 pi over 6. 60 degrees is equivalent to 1 pi over 3. On a 1 through 5 scale right now, understanding how I just numbered the radian measurements that are equivalent to 30-degree increments. Can you have a 1 through 5 so I can see it? Not how fast you can do it, your level of understanding. Most of us are 3s and 4s. Okay. So the only thing I have not done so far is I have not done the 45. So the next one I'm going to do is the 45-degree increments. And I'm going to color this in. You're just watching again. So I'm going to color in, just like I colored in the first 30, I'm going to color in the first 45 sector. Okay, ask yourself this and respond to your partner. How many equivalent sectors this size are contained in the top half of the unit circle? So I see 2, I see 4. Okay, here's 1. There's a second one. There's a third one. And there's a fourth one. Does everybody see that? Okay, so 4. I came up with 4 in the top half. Why is that important? Because now we're going to start counting on the outside of the unit circle at the 45-degree increments. So this is your first sector. That does not show up well. Give me 1 second. This is 1 pi over 4. Here's your second one, 2 pi over 4. Third one, 3 pi over 4. Fourth, 4 pi over 4. The bottom half, 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4. Where I put a circle with the highlighter, thinking of this almost like a compass, north, south, east, west, I want you to turn to your partner and I want you to examine what did we receive after we reduced the 30-degree increment? What did we receive after we reduced the 30-degree increment? And how does that relate to the new number I just placed in that position? 30 seconds, go. Okay, does anybody have an answer for me? How do they relate? Justin, thanks for raising your hand. What do you think, Justin?
We said that it just reduces to pi.
It just reduces to pi. I like part of that statement. So I'd like you to show me how, okay, 3 pi over 6 reduced to 1 pi over 2 when we did 30-degree increments. But you're telling me that 2 pi over 4 will just reduce to this the number pi? It reduces to the exact same fraction. What does 2 over 4 reduce to? 1/2. It's the exact same thing. What does 4 over 4 reduce to? 1 pi. What does 6/4 reduce to? 3/2. And what does 8/4 reduce to? So here's the trick. When you think about increments of 45 degrees, just watch. 1, 2, 3, 4, 5, 6, 7, 8. There is 8 of them. But if you do the 30 degrees first, do I have to worry about, if we think of as compass, do I have to worry about these north, south, east, west points? Because they've already been done for us. So you only have to worry about these. There's just 4 of them. You only have to worry about these. And now here's a trick to doing it quick. This is the first one. What's the number on the bottom? Denominator. 4. 1 pi over 4, go up by odd numbers. 3 pi over 4, 5 pi over 4, 7 pi over 4, done. Okay? All right, it's time to challenge you. I need you to have a blank unit circle in front of you. We're going to take what we learned yesterday, what we just went over, and we're going to apply it. I'm going to do the first 3 problems with you because this was confusing for students. So pay close attention. And just a little bit, you're going to have partner A and partner B. Just pay close attention. Okay, I'm going to circle a point for you. And I'm demonstrating right now what you're going to be doing with your partner shortly. And the first thing I'm going to ask you is, what is the ordered pair to this point, and how do you know that? So, okay, what is the ordered pair? Well, I know I'm going to do the shortcut method. I'm going to make that U shape. So it's 1, 2, 3, 1, 2, 3. So it starts with the 1. So the square root of 1 is 1. 1, 2, 3, 1, 2, 3. Square root of 3 over 2. This is my answer. How do I know that? Because I made that U shape. Okay, starts with a 1, and I know that if I start with a 1, the next one's going to be a 3. The next question is going to be, what is the degrees? I know this is a form of a 30-degree increment. So 3, 6. 6, add a 0 and a degree symbol, they're 60 degrees. The third part is, what is the radians? Well, I know again, when I count by 30s, I get to use radian measurements that are 1 over 6 because there's 6 different equal sectors on the top. So 1 out of 6, 2 out of 6. So although this is 2 pi over 6, because it's the second sector, what does 2 over 6 reduce to? 1 pi over 3. Thumbs up or thumbs down if you understood that. Okay, here's the next one. Let's make it a little more complicated. So what is going to be the ordered pair? So the first question you ask yourself is, how many degrees is it to get back to the x-axis? So is it 30, 45, or 60? And by the way, here's the way you can do this on your paper. Literally put your finger on that point and back to the x-axis, and then like freeze your hands, don't move them, and come back up here and see what is the measurement. It is 30 degrees. So I want to start by knowing, first of all, what is this ordered pair? Because this angle is similar to this angle. It's a reference angle. So how do I get this number? Again, I'm going to make that U shape and I'm going to count. 1, 2, 3. Okay, so 3 goes first. And if 3 goes first, I know 1 has to go second. Common mistake, and even often made by me if I'm rushing, is I forget to ask myself, this is quadrant 3. In quadrant 3, what are going to be the signs on both of these? Remember, we're so accustomed to saying this is like your x and your y value, but in trigonometry, this is the cosine and the sine of an angle. Okay, next up, let's go with what is the degrees. So I'm going to count by 3s. 3, 6, 9, 12, 15, 18, 21. Add a 0 and a degree symbol. And now I'm going to do radians. So I'm going to count by 6s because it's a 30-degree reference. So 1, 6, 2, 6, 3, 6, 4 over 6, 5 over 6, 6 out of 6, 7 over 6. 7 out of 6 does not reduce. 1 to 5, what is your understanding right now? 1 to 5 so I can see. If speed is not a factor. Okay, we're doing pretty well. So here's what I'm going to have you do. I need you to have a blank paper in front of you that you're not going to write on. Also have out your lined piece of paper. Doesn't have to be neat. Does not have to be neat. We are going to do 6 problems. You will do 3. Your partner will do 3. When I assign you a problem, I'm going to time you. You need to explain the entire time to your partner how you got this answer. It is your partner's job to listen carefully to make sure that they're explaining it right and they have the correct answer. If you happen to be a person who's in charge of explaining it and you're like, I don't know how to do this, then just ask your partner for help. Decide right now who's partner A and who is partner B. Okay, partner A is raise your hand. Partner B is put your pencil or pen down. You are there solely to listen and to correct them if they are wrong. Partner A, I'm going to circle a point. You're going to see a timer pop up. When I say go, you're going to have the amount of time you see on the screen to do 3 things. What is the ordered pair for the point that I'm going to identify? What is the radian measurement and what is the degree and how do you come up with those? Not just, hey, here's my answer. How did you come up with those? Partner A, this is your point. You have 1 minute starting right now. Begin. Can we do it first then? You explain the entire time as you're going. Okay, so what nice job. Stop. Switch partner roles. Switch partner roles right now. Again, put your pencil or pen down if you are the person that's listening. Okay? Your 1 minute starts right now. Begin. There's always one in the group, Omar. Good? Okay, and stop. All eyes up here, whether you are done or not. Excuse me. Let me go over the last two answers. This is a 60-degree reference angle because it is 60 degrees back to this x-axis. So the ordered pair down below would be positive 1/2 and negative radical 3/2. The degrees is 300 and the radian measurement is 5 pi/3. Up above, this is a 30-degree reference angle because it's 30 degrees back to the x-axis. Over here, it is negative radical 3/2 and positive 1/2. Degree is 150 degrees. Radical measurement is 5 pi/6. What if I said to you this simple question? What is the cosine of this point? Turn to your partner. What's the answer? What is the cosine of this point? CBS, cosine before sine, CBS. So here's my cosine. What is this number? It is negative radical 3/2. Turn to your partner. What is the sine of this position? What is the sine? Well, the ordered pair down here is 1/2 and negative radical 3/2. The sine portion is the second number, so again it is negative radical 3/2. 1 through 5 right now in your understanding, 1 through 5. Okay, most of us are 4s and 5s, so I'm only going to do 2 more before we take a practice quiz. Go back to the first partner. First partner, this is your position. You have 45 seconds. Ready, get set, begin. Okay, here we go. What is this ordered pair? The ordered pair is 0, 1. So 0 is the cosine, 1 is the sine. 0, 1, 0 cosine, 1 is the sine of this position. This is 90 degrees. It is also pi, 1 pi/2. All right, the last person. Here's your last one. 1 minute in this position. 1 minute. Begin.
See, when you do the patterns, it messes me up. So I have to do the mental math. Like, oh, it's this far away from this quadrant, so I only have to.
Okay, so this is a 45-degree reference angle. 45-degree reference angle. The nice thing about 45s is they are easy to memorize. Before I think about positives and negatives, remember all 45s are radical 2 over 2. But in this position, third quadrant is going to be negative radical 3 over 2, common negative radical 3 over 2.
When you
It's
say radical 2 over 2,
negative, did I say negative radical 2 over 2?
you said radical 3 over 2, or 3 over 2.
Oh, sorry, I meant to say negative radical 2 over 2 both times. Thank you. So negative radical 2 over 2 and negative radical 2 over 2. The degrees is 225 degrees. The radian measurement is 5 pi over 4. Okay, so really quick, I need you to raise your hand if you understand. If I point to any position and I give you an adequate amount of time, could you tell me what the cosine is or what the sine would be if I gave you enough time? Hands up high if you can't. That's okay. I just need to see where you are right now. Okay, look at yesterday's notes. I want you to look at tangent. What do we talk about tangent?
Is sine of
So although you learned SOHCAHTOA, and TOA is tangent of an angle is opposite side over adjacent, we also can say it is sine divided by cosine. Does everybody understand that? Okay, you're going to take a practice quiz. I need you to have a blank circle out, so blank circle out. And I need you to have a piece of paper where you can write down the answers, and then we'll go over them. I'll leave mine up here. Here we go. Needs to be quiet. We have 10 problems. Your goal is to get a 70% or better, just a goal. Give me 1 second. Okay, so here's your first one. I'm going to point to a position on the unit circle, and on your paper, you are going to write down the equivalent radian measurement. Is everybody ready? This position, what is the radian measurement? That's number 1. Okay. Give me 1 second here. Okay, here's your next one. Don't write this down. I want to know when you find this position on the unit circle, and you're only considering going around one time around the circle, okay? One revolution. When you find this position on the unit circle, what is the degree measurement? Number 3. Please find 7 pi over 6 in the unit circle and write down the ordered pair that corresponds with 7 pi over 6. Ordered pair, please. Okay, next up, please write down the ordered pair for 30 degrees. Are you on number 4 right now? Okay. Going on to number 5. Number 5. What is the cosine of 135 degrees? What is the cosine of 135? Number 6. What is the sine of 210 degrees? What is the sine of 4 pi over 3? What is the sine of 4 pi over 3? Are we going on number 8? Going on to number 8, okay. What is the tangent of 90 degrees? With 5, oh, we have 10 minutes left, right? Okay, we're doing okay. What is the tangent of pi over 4? Bless you. Okay, let's go over the answers right now just to see how many you have correct. Did we end up completing 8 or 9 problems? Okay, help me out here because my sticky notes did get arranged in a different order. I believe the first problem I gave you was number 1 was, what is this in terms of radians? Is that my question? 11 pi over 6. 11 pi over 6. My apologies for the confusion. Does anybody know what, I know what my third question, anybody know what my second question was?
And the answer.
Let's skip it and come to the third one right now. The third one is oh, I'm getting messed up right now. My third one is I think I provided you this sticky note, and I said, what is the ordered pair to it? Am I wrong? This is number 3. What is the ordered pair to this? No? Dang it, my sticky notes got messed up. Dang it. Tell me your answer to number 2. What is it? 315. I have 315 as on my answer key, but I can't find the sticky note. Darn it. Okay. Here's 315. I provided you this, and I said, what degree is equivalent to this? That must have been it. This is number 2. I must have provided you this and said, what is the degree that is equivalent to this? It was 315. Go with me. Say, yeah, you're right.
Yes,
Make me
yes,
feel better. Okay. Then the next one is, I think I provided you this, and I said, what is the ordered pair? Yes? Okay, the ordered pair to this is negative radical 3 over 2 and negative 1/2. Okay, the next one was 30 degrees, if I'm right. So this is number 4. And I said, what? Okay. Number 4, I said, what is the ordered pair? And it is positive radical 3 over 2 and positive 1/2. Then I asked you, what is the cosine for number 5? What is the cosine of 135? So 135 is right here. The cosine is negative radical 2 over 2. Then the next one is, I said, what is the sine of 210? 210 is right here. The sine being the second number, like the y value, should be negative 1/2. Number 7, what is the sine of 4 pi over 3? 4 pi over 3 is in this position. The ordered pair, first of all, remember this is a 60-degree reference angle. The ordered pair is negative 1/2 and negative radical 3 over 2. And I asked, what is the sine, the second number? So the sine would be negative radical 3 over 2. So just curious right now. That should take us through 7 problems, right? How many of you were able to get a total of 4 right or more on those? 4 or more right. Impressive, okay. Now for the 2 hard ones, I asked for the tangent of 90. So remember, tangent means the sine divided by, sine of 90 in this case, divided by the cosine of 90. So in this position, the ordered pair is 0, 1. 0 is the cosine, 1 is the sine. So I'm taking 1 and dividing it by 0. But any number divided by 0 is actually said to be undefined. So the tangent of 90 degrees is undefined. Did anybody have that in this classroom? Sure you did, Shipley. Okay, I believe you. Now the next one is the tangent of pi over 4. Pi over 4 is in this position. Same thing, tangent is sine divided by cosine. But the nice thing about these numbers is they are identical. They are both radical 2 over 2. So when you take the same number and you divide it by the exact same number, what do you always get for an answer? 1. So here's the cool thing. You ready? Because these 45s that I'm pointing to right now, these reference angles of 45, because they have the exact same numbers, just different signs, this is going to be a positive 1 tangent. What is this tangent going to be? Tangent of 135. Is it 1 or negative 1? Why? Because they're different signs. One's positive, one's negative. What is the tangent of 225 going to be? Because they're both. And what is the tangent of 315 going to be?